Okay, so hello everyone, very good morning everyone, very good morning to all of you present up over here. Welcome to the live session only under the YouTube channel Unacademy Computer Science. So how are you all doing? How is everything going at your end? And how are your preparations going for GATE 2024 guys? Do let me know in the chat box, and whosoever has joined us, drop me a hi or maybe yes or anything in the chat box so that I get to know you are over here, and we'll be starting in for today. Okay. Very good morning, Usha, very good morning. Very good morning, I love India, very good morning. Great to have you guys over here, great to have you. We'll be starting off with a little bit of offers and everything which is going on Unacademy, okay, till the time everyone else will also join. And we'll be like starting for today, okay. So right now what you could do is that you can save to 60% off with just 6 months of free extensions onto the GATE ESE and CS and IIT subscriptions. Right, so whatever the batches are gonna be for 25 for 2026, for them the subscriptions have already been started, okay, for the ESEs and for the CS and IT. So the batches, you can just join the batches which are your Prarambh and the Vishwas batches for your GATE and PSC 2025 and 26. Which is going to start on 16th of December. That is yesterday, it already started out, okay. Still if you want you can enroll into that. Very good morning, Om, very good morning. So still if you want you can enroll into that, okay. You can just go ahead, take the subscription. So even right now you're going to save to 60% off for the same. So what you have to do, you have to use in my code which is SHA10 for getting the maximum discount over your courses, for buying up the courses, right. So right now we are having two kinds of the subscriptions which are available for you people, that is a plus and the iconic, okay. The durations for those are exactly same. Duration starts from 12 plus 6 free months, 15 plus 6 free months, and 24 plus 6 free months. Durations for both of them are exactly the same, right. What differs is all about that what features you are getting in the plus and the iconic, and what exactly amount you have to pay in terms of the amount, right. So that is just two features which are like different in terms of plus and iconic subscriptions, right. So you can use in my code, again I'll tell you, SHA10 for getting the maximum discount for the same. And for more details you can always reach out to 8585858585, and you can just get in and clear all your questions, all your doubts for the same, okay. Further, again I was telling you, with the 6 months of free extension you can save to 60% off onto the GATE CS and IT subscriptions. So let's talk about that. What do you get in terms of the benefits for between the plus and between the iconic, okay. So in terms of benefits, so the plus benefits you get under the plus and the iconic, both kind of subscriptions, okay. High quality printed notes, you do not get that in the plus, but yeah, you get that in the iconic. One-on-one live mentorship, you do not get that in the plus, but you get it in the iconic. Customized doubt solving, do not get that in the plus, but you get it in the iconic, okay. So here are some difference between the benefits which you get in terms of plus and in terms of iconic, okay. And for the 12 plus 6 free months of the discounted price for the plus, it is 33,839, and for the iconic is 44,639, okay. And further it differentiates for the 15 plus 6 free months and 24 plus 6 free months, right. That is how it is completely done. And again, this offer was valid till 16th of December till yesterday, but still if you enroll you will be getting this particular offer, and you can just apply for the same, right. For doing so, you can just use in my code SHA10 for the same. So talking about the Prarambh batch in detail, so this batch is for the GATE and PSC 2025 for the CS and IT students, okay. So it started yesterday, that is on 16th of December, okay. Language is gonna be Hindi plus English. It's gonna be the CS, and this is gonna be the batch number 8. So the very first batch for your 2025, okay. So you get started with the C programming and data structures and the computer network. So that is what you might have been started with yesterday already. Mentioned over the screen are all your instructors who will be teaching you during this batches for the Prarambh and further going ahead for the same, okay. Talking about the Vishwas batch, you can use up the GATE and PhD 2026 for the CS and IT. It is also started on 16th of December. Language is Hindi plus English, CS, and that is also going to be the batch number 8. So you started with C programming and data structures and followed by your computer networks. So the people who are going to take in the iconic subscriptions, for all of those people, you will be getting the books, the handbook of the different topics delivered to your home within 15 days, right? So if you are going to take the iconic subscriptions with all the features that I listed before, with all of them, you will even be getting these list of books delivered at your home within 15 days. Okay, the books will be about the digital logics, operating system, programming and data structures, theory of computation, computer networks, database management system, compiler design, computer organization architecture, discrete mathematics, algorithm, engineering mathematics, and aptitude. Okay, you'll be getting the books for all of these topics. So nothing can stop you from chasing your GATE, CS and IT dream. You can get started with a no-cost EMIs and 0% interest onto the loan for as low as rupees 3,599 per month. So in case you cannot take the course completely in one go, you can just go ahead with this EMI option. Okay, and with the help of this EMI option, you can take the course and further you can do the payment every month for the same. So the process is too simple. You can just start with the things. You get the approval in 2 hours. You have the minimal paperwork and a flexible tenures also. Okay, this is all what you get. So here this All India mock test for GATE 2024 is over here. So if you just want to have an experience just like the GATE exam, you can just enroll for the this particular exam which we at Unacademy is conducting. It is on 17th December and 24th December. One exam is today itself, right? So what you'll be getting clear idea that how does a GATE 2024 paper completely looks like, right? And even you'll be getting a timing of 3 hours to solve that complete paper. Okay, so you'll be having a very good experience in terms of GATE 2024 exam. So here you're having this QR code. You just have to scan and enroll completely for free, right? And the exam for the CSIT and EE students will be 9:30 AM to 12:30 PM, and for ECE, CE, ME and CH it is 2:30 to 5:30. Okay, talking about the rank, whatever you score. So if you score the rank between 1 to 10, you get a 100% scholarship. If you score rank between 11 to 60, you get a 75% scholarship. 61 to 250% scholarship, and 201 to 525% scholarship. So this is how all the scholarships have been divided in terms of what rank you exactly score. Okay, and these are all the Unacademy learners who have already cracked. Many congratulations to all of them over here. Fine everyone, so this is what I had in terms of things to let you know what exactly is right now going, what offer is going on, what are the, I would say, the exam into which you can enroll and everything else, right? Fine. So we will be starting on with our today's topic. So today we are having feed-forward neural networks, right? So we will be learning what exactly feed-forward neural networks are, what exactly you have there, right? And applications, right? What layers you have in over there. We'll be learning all those things over here. So, but just before that, whoever has joined in the class, just drop me a hi or maybe yes in the chat box, so that I get to know you are here, and then we'll be starting in for today. Till the time, I'll just open the OneNote also. Yeah, whoever has joined, guys, just drop me a hi or maybe drop me a yes in the chat box. Okay, just a minute. Yeah, just allow me a minute, guys. I'll just open the OneNote and we'll be starting very soon onto that only. Just give me a minute. Fine, so maybe everyone has joined, and guys, if you haven't shared this live stream yet with your friends, so just go ahead, share this live stream with your friends so that they can also join in the session in case they want, and they can also come up over here and we can all learn together. Okay, so this was the multi-layer perceptrons which we discussed in yesterday, right? I told you what multi-layer perceptrons are, what do you have in terms of the diagram, how it works. We even talked about your layers also, right? So then we worked with the sigmoid activation function, right? We discussed about difference between ANN and MLP. Fine. We did a stepwise implementation too. So yeah, these were all the things which we had done yesterday. So I'll just start on with a new note for today, and what we are going to do, we'll be starting on with what are the feed forward neural networks. Okay, I'll be giving you a very clear idea about the same. Okay, a few more things about feed forward neural networks, because see, this maybe this is something which need not to be discussed in very much detail, but yeah, at least you need to have in some idea about that. What are feed forward neural networks? What do you have inside it? Like how does the architecture look like this? Look likes in this. And yeah, these kind of information is important for you to have it. Right, so just let me put the heading for today. So we are having for today feed forward neural networks. Fair enough. Okay, so let's do one thing. Let's start on with the session. Okay, let's start on what we have in terms of talking today under the feed forward neural networks, right? So see, the very first thing is that feed forward neural networks, these are artificial neural networks. Okay, these are actually known as your artificial neural networks, in which what do you have? Actually, we are having nodes, right? Yesterday I told you that we have the nodes in all of these neural networks, right? So we have the nodes in these neural networks thing. So what happens, these nodes which we have up, they do not form the loops. That is what you have in terms of feed forward neural network. Yesterday when we discussed for the multi-layer perceptrons that they form a loop. How they form a loop? That inputs have been transferred to the hidden layer. From here, hidden layer, you get the outputs, right? Each and every of these inputs have been connected with each and every single nodes in the hidden layer and the things like that, right? Like we saw yesterday that for one node, it is connected to every other nodes in the hidden layer, right? One input node is being connected to each and every other hidden node. Fine, we saw that yesterday. So that is what it is called as making the loops, right? This is what exactly we term as which is helping us to form up the loops. So in terms of feed forward neural networks, you do not have anything like that, right? Here what happens, here nodes are not formed. Okay, you do not form the nodes with the help of form the loops. Okay, so you won't see over here that from input it has been every node has been working with each and every other node of the hidden layer and things like that. You won't see that in this particular feed forward neural networks, right? So we will keep on writing also so that it doesn't afterwards we don't forget up the things. So I'll just simply make one sentence, and that is, it do not forms loop. Do not forms loops, right? So yeah, always remember about the feed forward neural networks that they do not form outer loops, right? Now, this this particular feed-forward neural networks, we also say this as a multi-layer neural network. Okay, multi-layer neural network, and the reason is that here all the information is passed forward only. It means that, see, from the name only it is said feed-forward neural network, right? So what happens? Whatever information we have for us, it gets passed forward only. Okay, all the information that we have, that gets passed forward. So this is also known as multi-layer neural network. I will just write that also, multi-layer neural network, right? This is the other name for the feed-forward neural networks. So what happens when we work on with the data? Okay, when we work on with the data, so whatever the data is being worked, like on whatever the data is being working, so that respective data flow, what happens? Input nodes receive up the data, right? Input nodes receive up the data, which travels through the hidden layers and exit the output nodes, right? As see over here, we work with the first of all input, then hidden, then output, right? That is how the mechanism works in. First of all, we work with the input node, then it goes to the hidden layer, and then it goes to the output, right? This is how it is being working. So whatever the data flow we are having, that data first of all goes in the input, okay? It travels to the hidden layers, and then it exits with the output. That is the complete procedure for this respective feed-forward neural networks. Okay. This is the whole process. How does this respective input, hidden, and output thing works in, right? So here there is no such link between that. If you just want to get any information back, travel to the back, right? You just can't do that. There is no such method over here for the same. It was in the multi-layer perceptrons, you might be able to do that over there, but over here into this perspective, that is your feed-forward neural networks, you cannot pass the information to the back. So one information if you have put in the input, it will go to the hidden and then to the output. It can't come back from output to the hidden in case maybe you missed any information or any information is not needed. So in that case, nothing would be done, right? Just very simply, you can't take the information back from here, right? Back from the output node, it is not allowed in the feed-forward neural networks. So remember this particular thing. This can be something which can be asked to you, that which neural networks doesn't support about sending the information back to the output, back from the output node, right? So in that case, you can say this feed-forward neural network. Okay, now that is something which we have over here. Now how does, okay, if I talk about what is the practical implementation, like where in real life this feed-forward neural networks have been implemented. So you have learned about this Google Photos app. Like everyone has used up the Google Photos app, right? So this is how and this is exactly a place where feed-forward neural networks are being served in terms of the real life. Okay. So what they do, they help you to identify and they help you to actually detect the object. What happens in a Google Photos, right? You have different folders automatically made, right? You get the different folders made, you get them all the images sorted according to the date, right? These are what you have. So what happens in the Google Photos, this is an exact application of your feed-forward neural networks, right? Because it is automatically getting saved to the Google Photos. If you just link in your account, the images, whatever you are going to click in, that will automatically go and save into Google Photos, right? That Photos app. Now, you can't send that back. As I told you, input, hidden, output. So whatever you have passed in the input in terms of saving a photo onto the Google Photos, you cannot send that back from the output to the input. What you could do is you can delete that from there, but you cannot save or you cannot send back your photo to the normal gallery if once you have saved in the Google Photos, right? That you can't do. So this is where the application is about your feed forward neural networks. So this is one of the most important and real life examples of the Google of this particular feed forward neural networks. So am I clear with this thing to everyone, guys? Okay, fine. Let's proceed in everyone, and now let's move ahead and see that what is the working of a feed forward neural network. Like exactly how does it works? Fine. So what do we have to do? We'll start on with putting up all the inputs, but in between I would just, let's say, put some kind of a hidden layer like this. Okay. Now, see here what will happen. Now, as many inputs you will be passing. Let's say, this is my very first input. Okay. This is my second input in terms, let's say this is my third input, fourth input, and this is my fifth input. So see, whatever the inputs you will be passing up over here, right? These are, let's say, my 5 inputs which I had put down over here. I'll just name them, let's say X1, W1, X2, W2, X3, W3, X4, W4, and X5, W5. Fine, let's say these are all the inputs which I have taken. So this is all of my inputs. Now for all of these inputs there will be one output. Excuse me, guys. For all of these inputs there will be one output. Maybe let's say Y, or maybe 0 or 1, whatever my output will be, it will be my respective output. So now just try to listen up over here. Whatever the inputs you have given up over here, whatever the inputs you have entered up, right, these are all of my inputs, which these different lines I am using now, these all are my inputs, and goes over here, this line which is pointing towards something, that is my output term, that is my output for the same. So see, this is how, and this is exactly that how a feed-forward neural network looks like once we are having any working onto this. Okay, whenever you have to do any working, whenever you have to use that in terms of working, this is how it completely looks like. The inputs, as many inputs as you want, you can put. There will be only one single output for all of the other inputs which you are putting in. Okay, there will be one single output. For as many outputs you want, you can just put that. Fine, this is one something which you have up over here in terms of working with the feed forward neural networks. Okay, so what happens, what is the thing which happens up over here? So whenever you have the feed forward neural networks, right, those get simplified, right? It simply appears, it can exactly appear as a single layer of the perceptrons. Yesterday I told you what perceptrons are. These are the building blocks of a neural network, right? Yesterday I told you about same. So how does it exactly work? It exactly works in a case na ki it can, whatever the feed forward neural network gets simplified, right? It can simply appear as a single layer perceptron, right? So what happens? What is the model we are building, right? So that multiplies the inputs with the weights and they enter up the layer, right? So then further, whatever the weighted input value we are having, that completely gets added together to get the total sum. And as long as the sum of the value is gonna increase above a certain threshold. Maybe let's say it is gonna increase above 0. So the output value is usually 1 in that case, right? So that is how a feed-forward neural network exactly works in, right? Whatever you are giving up over here in terms of the inputs, those get summed, those get added out, and they are having up a certain threshold set, let's say as 0. So whatever the number you will be getting above that, whatever the input will be above that, that will be all added, and that is how it exactly works. Okay, that is how it works in terms of your working. Now if I talk about, there are different layers in the feed-forward neural network. Okay, there are different layers under the feed-forward neural network. So let's talk about the very first layer. Let's say that is my input layer. First of all, I'll name all the layers, then we will be further discussing in detail. So first layer we are having the input layer, second we are having up the output layer, right? Then we have a hidden layer. Then we are having up a hidden layer, right? Next, what do we have? We have the fourth thing as neurons, neuron weights. Neuron weights. So if yesterday you have attended my class in the when we have discussed about the multilevel perceptron, there we discussed about the weights, the bias, these layers, everything we have discussed in, right? Okay, Kabir ma'am, आपकी DS या PLS में कौन सा subject fully complete है वो बता दीजिए. Okay, Kabir, we have Python and data structures and algorithms completed for your DS and AI. We have Python and data structures and algorithm completed. Okay. So yeah, we are having this neuron weights over here. Next we are having the here as neurons, and last we are having the activation function. Activation function. Fine. These are all the layers which we have up over here in the feed-forward neural networks. These are all the feed-forward neural network layers. Right. So let's see in detail about each and every one, that what does that respective layer means and what is the use of that particular layer. So very first, let's talk about the input layer now. So whatever the neurons are there, so whatever neurons we have into this input layer, they receive up the input, right? And what they do, they pass that on to the other layers of the network. That is what is the use of the input layer. So whatever the inputs you will be receiving, all the layers of all the neurons of this layer will receive that input and they will pass it on to the other layers of the network. This is what input layer exactly helps us to do, right? So now there is one condition also under the input layer. That condition is that whatever the features or attributes in terms of numbers we are having in the data set, okay, whatever the features or attributes in terms of numbers we are having in the data set, that must match out your number of neurons in the input layer also. So features and the number of neurons of the input layer, both of them should match. This is a condition for your input layers. Okay. Next, further moving ahead, we have the second, that is the output layers. Right, so according to whatever the type of model you are getting to build, this particular layer represents up your features of the complete data. Whatever is a forecasted feature, it will help you represent. Forecasted feature means that when we pass the if we have multiple inputs in terms of layers, so we are going to pass that multiple layers of the input, right? And further with that multiple input layers, it is going to sum up and give one single output, right, in terms of the output, right? So that is how this output layer works, right? So according to the type of the model which is getting built out, this layer represents the forecasted features, right? That is how it is working. Next, third, we are having our hidden layer. Now, whatever is the input and whatever is the output, right? You know, we have inputs and we have outputs, these two layers, right? So these two layers exactly get separated with the help of your hidden layers only. Okay, input and output layers, they get separated with the help of your hidden layers. Okay. Now, depending upon what kind of a model it is, the layers get separated. There are several hidden layers, right? So what happens? Key input layers and the output layers, they just get separated by a hidden layer, working with that hidden layer, and it just depends at what kind of a model is being used out. Just depending over that, you are having the hidden layers also. Right, so everyone, am I clear till this particular place, guys? Am I clear till this particular place, like how and maybe exactly how is it working? What do we have in terms of working over here? Okay, Kavyashri, rest everyone, are we clear? Yes guys, everyone clear with the same? Okay. Next we will be discussing about the neuron weights. Okay, let's see what neuron weights are. So what happens? Neurons actually, they get connected by a weight. Okay, neurons, they get connected by a weight. Okay, which measures their strength or magnitude. Okay, which helps to measure their strength or the magnitude. Like just linear, okay, when I told you about the linear regression, so there we have discussed about y is equal to ax plus b, right? So we are having the coefficients also in the linear regression, right? So just like we are having the coefficients in the linear regression, just in the same manner, the input weights also get compared. The input weights can also get compared over here, right? So weights are just normally between a 0 and 1, where we have the value between 0 and 1. So what are neuron weights? Neurons are whatever the neurons we are having, they just get connected by a weight, which measures the strength or the magnitude. Okay, similar to the linear regression coefficients. So input weights, they can also get compared. So weight is normally between 0 and 1, with a value which is going to lie between the 0 and a 1. This is what neuron weights are. Okay, just for measuring their strength or the magnitudes, the neurons get connected by a weight. Okay, now let's even see the neurons, the point number 5, the next layer, which is the neurons. So let's talk about artificial neurons. Right, so they are used in the feed-forward networks, which actually is kind of that a neural network exactly consists of the artificial neurons. Right. So how a neuron works? They just work in two methods. The very first one is they create weight input sums. Okay, they create the weighted input sums. The very first method, what they do, they just create the weighted input sums, right? And second, they activate the sums to make them normal. Second is activate the sums to make normal, right? So they just activate out the sums as well to make them normal. These are the two methods how the neuron functions exactly, right? First is they create the weighted input sums, and secondly is that they activate up the sums for making them normal. So this is what neurons exactly like do, right? So what are the activation functions we are having, right? What are the activation functions we are having? They can just work, they can be in two methods, right? Either they can be linear or they can be non-linear. There are two different methods that are like maybe how activation function can be. Either they can be linear or they can be non-linear. These two methods, right? So this is how it works. And now if I talk about the activation function in the detail also with you all, right? Activation function. So see, neurons are responsible for making the decisions, right? So we know that neurons are responsible for making up the decisions. So according to the activation function, okay, according to the activation function, so the neurons which we are having, those help you to determine whether they have to make up a linear or a non-linear decision. Okay, so according to activation function, the neurons which we are having, they exactly help you determine what is to be made, right? In terms of whether a linear or non-linear decision has to be made, because we know that we have to set down that what kind of a decision is to be made, what kind of a decision is required, right? That is how. So it even prevents your cascading effects from increasing neuron outputs. Now, if the neuron outputs will also increase, that will also create up a problem, right? Maybe for selecting that what to choose and what not to, right? So in that terms, it helps you to reduce that particular work also, right? And activation function. Okay, now if I talk about the activation function again, so I need to write that over here because we have something. So activation function is being classified in 3 more parts. Okay, into 3 major categories. One is we are having the very first one as sigmoid. The very first part of the activation function is the sigmoid, right? Second, we are having tan H or tan, whatever you say, right? And the third one we are having as rectified linear unit. So activation function is also further divided up into these 3 parts. So everyone, am I clear till this particular place to all of you? Am I clear till this particular place to everyone, guys, that what exactly an activation function is and like how does it works? Everything, are we clear, guys? Yes, everyone, what are the types of our activation function? Maybe what are neurons? What is neuron weights? Are we clear with all of these things? Okay, oh, fine. What about rest? Okay, let's talk about the sigmoid, tangent and a rectified linear unit in the detail. Okay, let's talk that what are these 3. Okay, so sigmoid. So here what happens, the input values between 0 and 1 get mapped to the output values. What is sigmoid? What are the input values you are gonna have between 0 and 1, or maybe 1 and 0 and 1 I need to write. Yeah, between 0 and 1, those all get mapped to the output values. Input values get mapped to the output values. That is what you have under the sigmoid. Fine. Tanh. Whatever the values you are having between -1 and 1. Whatever the values between -1 and 1, that gets mapped into the input value. See, sigmoid gets your values mapped in the output. Okay, mapped to the output values. And tanh gets values between -1 and 1 mapped into your input value. So remember what is doing for the output and what is doing for the input, right? And next we are having your rectified linear unit. So here whatever the positive values are allowed. Okay, here only and only the positive values are allowed to flow through this function, right? So negative values get mapped to 0. So in case of rectified linear unit, if you have some value which is a negative value, so that will be said as, that will be mapped as completely 0, because under rectified linear unit only and only the positive values are allowed. not your native values are allowed. So that they get mapped to 0, right? These are the three things about the rectification functions of the sigmoid, tangent and the rectified linear unit, right? This is how these work. This is how they further move ahead further in terms of working of the same, right? Fine, everyone. So yeah, everyone, are you clear with the same till now? Is everyone clear with the three types of the activation functions also which we have up over here? Okay, fine, Om, fine. Okay, Kavyashree, fine. Okay, now we'll be discussing about the functions in your feed-forward neural networks. There are types of function, your cost function, sigmoid function, these types of functions, right? So now we'll be discussing about all of these in the detail. Okay. The very first function which we are having is your cost function. Okay, the very first function we have is your cost function. So see what happens in your feed-forward neural network. So the cost function, it actually helps you for a very important role, right? So whatever are the categorized data points, right? So these are little affected by the minor adjustment of the weight and the biases, right? So whatever data points have been categorized, right? So if you are going to do a very small or very little kind of the adjustment or arrangement, then also these weights and biases, those are gonna get affected, right? So what we do for a smooth cost function, right, we just use to determine a method for the adjusting the weights and the biases for improving of the performance. See, whenever you are applying up any method or maybe any function or anything, right, one of the main goals about the same is to make the just use that for the improvement of the performance also, right? Because how our function is working, what is the idea behind our function, what is the how is it working exactly, those all things are also which have to be taken care of, right? So for a smooth cost function, you can get used to the determine a method about adjusting up your weights and the biases for improving up the performance, right? So that is how exactly what cost function is, right? They plays an important role. They categorize data points which you're having, those get affected by the minor adjustment to your weights and the biases. Okay, that is what cost function is. Second, we are having the loss function. Okay, let's see what loss functions are. So see, in the neural networks, they exactly get used to determine that if an adjustment needs to be made in the learning process. While our model is being learning, while our model is being trained or the things are being followed, is there any kind of the adjustments which are to be made under that learning process, right? So what happens in the output layers, these are equal to number of the classes, right? Whatever neurons we are having in the output layers, those are equal to the number of the classes. So that is what happens up under your loss functions. They get used to determine if the adjustment needs to be made in the learning process. Okay. Kavishri, what are the possible questions from section? See, Kavishri, about the possible questions from this section, see, from this particular thing, a lot of theory kind of a questions can surely come, right? Maybe talking about the input functions, or maybe talking about the output layers or sigmoid, or talking about the activation function in detail, right? So a lot of tricky kind of a questions can be surely asked in terms of this particular module about this feed forward neural networks, right? Or maybe something, a kind of a use case can be given, and that it is can be asked in that what kind of a neural network is being used under this, right? So maybe what will you be using for the same? Okay, so that is something which can be used in terms of the using up of like maybe the questions which can be asked in from this particular place, right? This is what something that could be asked, right? Okay, very good morning, Pat. Very good morning. Right, so yeah, these are all of the functions. Fine, this is the functions and the things we are having up over here. Fine. Applications, I told you, there is one thing which is, yeah, absolutely, Pat. Surely you can just join in the classes. Not an issue. You can just come, ask in your questions. Okay. See, what is the aspirant you are? Maybe you are giving in this February 24 or maybe in 25. You can surely join the classes. Rather, it will be better for you because you will be getting many times to learn the things. And this all is what the number of times you are gonna get to learn these things, more better about the same, right? Because these are the kind of a trickier things, so it's better ki you should remember up the things in a good way. Okay, fine. Yeah, so everyone, am I clear till this particular page to you all? Am I clear like exactly what we have learned yet? Okay, very good to hear that, Path. Very nice to hear that you have completed your course till OS. So nice. Absolutely very good, very good. Okay, Kaveshri. Okay, fine, Path. What about rest, everyone, guys? I don't know why will you are not responding today. I'm not sure with that particular thing, but yeah, if you can just help me out with some answers, with some responses, it will be very better for me to get in terms, to get an understanding in terms that are you getting this particular things or not, right? Okay, Harshit. Okay, fine, guys, fine. Okay, let's talk about the applications of this particular thing, this particular feed-forward neural networks a little bit, because that is also something which is very important for us to like further go ahead and learn about, right? So the very first is like there is something which is called a psychological feed-forward system. Okay, what exactly it helps you to do? It helps you that to find in that how your heartbeat works. It helps you to regulate the heartbeats before the exercise, right? So with the help of feed-forward networks, it is like possible to identify this particular thing in a situation, because like how does the heartbeat maybe regulate before the exercise. This is one of the applications of the feed-forward system. Fine. Next is about the gene regulation and the feed forward. So now with the help of this particular application, what you could do, you can just detect out the non-temporary changes which are actually in the atmosphere, right? And this is how, like, this is particular thing, that non-atmospheric changes which are into the atmosphere. This is something which can be asked in, right? Using way learning like Hebbian learning, competitive learning. Yeah, right, Harshit, right. Automation. So automation control with the help of feed forward is something which is like really too much going into the market, right? See, automation and these are a kind of stuff which is involving, I don't think so there is anything kind of a algorithm or something which is doesn't include automation or something, because right now talking about the automation, talking about these things, is something which is really moving ahead, working a lot in that perspective case, right? So yeah, that is what we have like around in terms of the whatever we have in terms of the applications, right? So see, yeah, this is what feed forward neural networks are, guys, right? So they exactly are that feed forward neural networks. They do not form up the loops. Okay, Path, how many lectures have been done in this course from where I have to watch lecture to understand it? Okay, Path, so we started with what machine learning is. We started with the introduction lecture. So I guess already 10 around 10 to 12 lectures have been done, Path. Okay, so you can just check out the playlist of DS and AI. For the Unacademy, you can check out the playlist for the DS and AI for me, and under that particular playlist only you will get in all the sessions which have been done, okay, in terms of machine learning. So visit the playlist section, there you will be getting it, and from there you can learn the things and revise up the things also, okay. Okay, most welcome, Path, most welcome. Fine, so guys, I was talking about the loops, right? So feed forward neural networks, they actually do not form the loops. That is one thing which we have up under here, and that differentiates it also from the others, right? Harshit ma'am, but in general, cost function and loss function, both are same. Yes, right. Harshit, absolutely right. In general, these two things are something which is exactly the same. But yeah, here there is a slight difference between both of those, which even I told you about the loss function, the cost function, like little bit difference in the terms of the mathematical terms also. Okay. Kaveshri, can you please conduct a MSQ session? Also will be. Yeah, Kaveshri, I will surely be conducting. We have the classes scheduled till 20th. Okay, I've already scheduled them. So today is already 17th, just 3 days more. Okay, after that I'll be taking your MCQs and MSQ session only. Okay, after that 1 or 2 days we'll be solving a lot of questions, lot of MCQ questions or multiple choice options, questions. Okay. For the next, just for the next 3 days, the classes are already being scheduled. So we'll be going ahead with the topics only. Then we'll be taking the classes in terms of your MCQs. Okay, most welcome, most welcome. Fine. So yeah, I was talking about the this particular feed forward neural networks. Right? Then we have seen how does it works. We checked over the Google Photos are, that is what a real world example is. We looked over the working, we looked over the different layers about them, seen in detail about these all the layers. Then we learned about the activation function, its several parts. Then even we saw that what are different functions in the feed forward neural networks, and then we learned about all the applications of this, right? This is what all we have learned up till now in this particular which is your feed forward neural networks, right? So first of all, I just want to ask you people this, guys, do you people have any questions to me in terms of this feed forward neural network, whatever we have learned today? Do you people have any questions which you want to ask me out? Okay, perfect. No questions if. Okay, yeah, right. So guys, this is all what we had in for today. Our topic was feed forward neural networks. I hope like you all might have listened to things, and might you have made out the notes also, because there were some of the topics which were a little bit of theoretical, not little, a lot of theory, and a lot of conceptual things were there into this respective thing. Right. So hope everyone might have made out their own notes about a revision of the things afterwards and all the things, right? Fine, perfect guys. So in case you people do not have anything, I guess we can just end up this particular class for today, because this was all from my end, whatever we had in terms of learning, right? So from tomorrow we'll be going at 7 p.m. in the evening only, our usual time which we used to do the classes. Okay, just for today and the day before and the yesterday, we had the classes at 9 in the morning. From tomorrow we'll be having the classes at same time, which is 7 in the evening. Everyone, so just make sure you people are joining in the classes on time from tomorrow, which is 7 p.m. right? And we'll be very soon starting on with the unsupervised learning, okay, the algorithms and unsupervised learning, and we'll be very soon going to go and start with your multiple choice question kind of a thing, MCQs, that what could be asked, what could not be asked, and everything, right? So just stay tuned. Whatever the sessions have been scheduled, okay, do join those sessions, everyone. Already you will be seeing a lot of sessions are scheduled onto the channel, okay. Just do visit all of them once, okay. Do hit the notify button so that once I go live, you can just be notified and join in for the same in case you miss the timings or something, right? So thank you everyone for joining in this particular class, guys. Thank you everyone for being here. It was great having you all. I'll see you all tomorrow at 7 p.m. in the evening. Okay, now remember the time from tomorrow. For tomorrow, it is 7 p.m. in the evening. See you there. Till then, thank you everyone, and have a great day ahead, everyone. Bye and take care, guys.